So please welcome Konrad Windszus.
Hello, everyone. Thank you, Roman. My name is Konrad. I'm working for Cognizant Netcentric. And apart from that, you probably have heard my name in the context of several open source projects. Today, I'm going to talk about multi-tenancy in AEM. So multi-tenancy in the sense of really having multiple AEM applications, not one application driving multiple websites. That's not the thing that I mean with multi-tenancy in this context, but really multiple applications. And with that usually comes that you have multiple teams, and with that the human aspect of it. I was recently involved in an, I cannot really say project because it was tons of projects, so with a customer ecosystem, let's put it like that, where we faced the issue that there were lots of different implementation partners have been involved, each with multiple teams. The teams were talking to different business stakeholders. The business stakeholders don't communicate to each other. There is lots of different code bases. There's even more code bases than you have implementation partners. And obviously, there is very different requirements in terms of when should a particular feature go live. So they need to have decoupled release cycles. That may sound familiar to one or the other, so I'm going to share some insights on how you can best tackle those challenges. I tried to tackle that from 3 different angles. So the first angle would be the infrastructure angle, which highlights a little bit what Adobe provides in terms of multi-tenancy support kind of built into the product. So this talk focuses really on AEM as a cloud service, so there's little deviations when you still run an AEM on-premise. So in AEM as a cloud service, you do have the tenancy concept of Cloud Manager programs. So you can theoretically license arbitrarily many programs, and each program comes with a set of services and a set of servers, basically, which allows you to fully isolate tenants from each other. So you may theoretically run only one single AEM application on one single Cloud Manager program, but usually that is not reality. So what is much more real is that you often run multiple AEM applications on a single Cloud Manager program. And that means you have certain shared resources. One of the shared resources is obviously the production and stage AEM environment. You may have multiple dev environments, which you can dedicate to individual teams or individual AEM applications, but in the end you have to integrate all into one, last on the stage environment. And with that comes usually the requirement that the multiple tenants need to be isolated against each other. I come to that point later on. From a code perspective, each Cloud Manager program comes with arbitrarily many code repositories, and also nowadays you can use your external code repositories directly, meaning you can directly hook up with your external code repository the Cloud Manager build. Let's go back a little bit and highlight once more about the multiple Cloud Manager programs. So what I already mentioned is that way you can obviously completely decouple the individual AEM applications, but there's certain drawbacks of completely isolating that in multiple programs. So the biggest drawback from my point of view is right now there's no easy way to transfer content from one program to the other. So you need to be really sure right from the beginning what you want to set up where. Afterwards, moving things around, right now not that easy. So you should think hard about which programs should share which AEM applications should share a common program. Then there's obviously operational overhead of running those programs. Not everything is fully automated usually, so there is in fact some non-neglectable operational overhead you should take into consideration. And there's also additional licensing costs. So you have to pay a fee for that. So the licensing is not only bound to the amount of incoming requests, but also to the amount of Cloud Manager programs you actually purchase. Let's look at the shared resources per program. So I already mentioned the prod stage pipeline. There's only a single one per program, which deploys to a single stage and prod AEM server in the end. And that single program relies on a single canonical Git repository. That means everything you have to somehow aggregate into that canonical root Git repository. On the other hand side, there's other parts a little bit outside the regular AEM code, which is, for example, CDN or web server configuration, which don't come with a built-in concept of multi-tenancy. So there's only one place, so there's only one CDN config pipeline usually. You can split it up per environment, but usually not by tenant. So you have to come up with your own concept on how to separate those accordingly. And what is also shared is the variables and secrets, which are being referenced in OSGI configurations, for example. So that also has to be managed somehow centrally. How do you aggregate many Git repositories? There's actually two different solutions to that. One solution would be that you leverage Git submodules. Git submodule support is kind of built in. So when you set up a root Git repository leveraging Git submodules, that means that the Cloud Manager will automatically resolve the references, will clone it in a way that all the Git submodules are there in the correct commit ID, basically. The drawback with that is it adds complexity, and not all developers get immediately how to work with Git submodules. So what I usually recommend is that you keep the Git submodules in sync with a dedicated build job. So that allows a developer, for example, to work on one single tenant only without considering the environment around it. So only within one single Git submodule, as if it would be standalone, although in fact it's being aggregated in the reactor somehow. Git submodules are unfortunately not supported yet for all external repositories. GitHub has support. There's no support for the other ones yet. So for Azure DevOps, for example, there's no Git submodule support from Adobe yet. One other hint, which is unfortunately, I think, differently described in the documentation, is my recommendation would be to always use relative URLs in your Git modules file. So the Git modules file specifies which references you have and basically where those Git submodules are located. And if you use relative URLs, you can use arbitrary authentication mechanisms. So no matter whether you use HTTPS or SSH authentication. The other way to aggregate is doing it manually, obviously. So usually you do have a dedicated build job, which clones from multiple different repositories and then puts everything together and commits it to either the Adobe repository or some other remote repository. And that way, this newly built repository is used as a source for the Cloud Manager build in the end. A non-neglectable fact is also that you need to establish some kind of central operations, because even if you have, or particularly if you have lots of different teams, you need to establish a team which takes care of granting the according cloud manager permissions and also granting the according AEM permissions, particularly if you have multiple programs and multiple implementation partners being involved here. And someone needs to obviously take care of the deployment of the variables and secrets, which are not shared either. So second aspect of multi-tenancy is shared code. So usually, even if you have a very distributed landscape, you have the interest that certain aspects of your AEM applications are only written once and not multiple times. This is hard to establish later on, so I would recommend to think about that right from the beginning. Shared code is often more about human beings, I would say, than about technical issues. But let me share some insights here. What, from my perspective, usually works best. So you need to have clear responsibility. So you need to have one dedicated team which really feels responsible for the shared code, and also that means for the maintenance. So when there is a bug in there, when there's a security issue with that, that team should feel responsible to actually fix that. There should be a transparent backlog, so everyone should know what to expect in an upcoming version. You should restrict yourself to the basics, really. Shared code always comes with an overhead. Think about that. So not every feature which may be reused in the future makes sense to initially place in the shared code. Coming from an open source projects, it's all about collaboration. So what I would definitely recommend is come up with an environment which somehow fosters the collaboration. So that means you should have good tooling in place. So everyone should have access to the backlog, for example. Everyone should be able to clone the code repository. Everyone should know where it's actually being located. Everyone should be able to consume the shared code easily. This is all important, and it is important to have those clear rules and documentation so that everyone knows what to expect. Because some people often think, okay, that is a different team. I just throw over my requirement and they take care of that. Usually that doesn't work because that doesn't scale, obviously. What works much better is if a tenant says, okay, here's a cool feature, I would love for you guys to take over the maintenance of that. So tell me if that's of interest of other tenants as well. And then I just contribute that in a way which makes it available for the other tenants. Shared code is also much about backwards compatibility. So you need to enforce certain versioning policies. And first you need to establish those. So what I would recommend is for Java code that you rely on semantic versioning. Since this is very hard to manually enforce, there's some tooling around that. Unfortunately, that does only cover the Java part of it and not really the rest of the ecosystem, like all the scripts you might have, all the dialog definitions you might have. All the HTML, which itself you might consider as an API, and therefore there are very good hints being established and documented in the wiki for the WCM core components. You should have a strict rule around multiple versions in parallel. In the best case, a version is fully backwards compatible, but that's not always feasible. I would recommend to not maintain more than 2 versions in parallel, otherwise it becomes easily a maintenance hell. Hello, core components. So how do you consume that shared code, particularly when it comes to, you do have, for example, multiple programs. There's 2 different options on how you could do that. So one option would be to consume that in binary form. That means you just consume the artifacts from a custom Maven repository. And the other option would be that you build it with each program individually, usually in the form of Git submodules. So you reference really the source code of the shared code. Small hint around AEM Analyzer Maven plugin. Usually the AEM Analyzer Maven plugin only sees the context of the current container package. So if you have multiple container packages which you want to deploy on the same program, then you need to make AEM Analyzer Maven plugin aware of that fact. So you need to tell it, okay, this does not run standalone, but there's also some other pieces which are always being deployed. Otherwise, it will fail, and it will rightfully complain about missing packages, for example. Yeah, the CDN and web server configuration, you must make sure that this is part of the shared code, because this is somehow shared responsibility. As I said, like there's no built-in tenancy concept. You could usually come up with something like a templating-based design where you say, okay, we use a common template, and you can parameterize that template to a certain degree and use that template for basically every domain that you run from this Cloud Manager program. And then you need to think about how to automate the deployment. For example, with one password vault, but there's tons of different means on where to store your secrets in a way which is deemed secure. Git is not, obviously. Second angle, tenant isolation. If you don't come up with very strict rules on where a tenant or what a tenant should be able to do, then you usually end up with tenants stepping on each other's toes. So the most important critical thing is namespacing rules. And namespacing has several aspects basically in AEM. The most obvious thing which comes to mind is obviously Java packages, package names, but there's obviously a lot more. But it's not only about defining those rules, it's also about enforcing those rules. And sometimes it is not that easy to see whether a tenant is compliant with all those rules. Even if you have a very decent manual PR review, sometimes you miss, okay, the tenant is actually abusing a certain namespace or is overriding something from shared or from another tenant. So it is crucial that you enforce with tools that the namespacing rules, that everyone complies with them. One of those tools is the AEM content package namespace validators. And yeah, I'm not very good with inventing new names, but it's a very long one. But in the end, what it does, it validates obviously namespaces on content packages, so very speaking name. And on the other hand side, there is the Maven Enforcer plugin, which you can leverage to, for example, ensure certain namespacing within your POM already. Notably missing here is something which works directly on top of bundles. I mean, in the end, bundles are always deployed via content packages, so they are also contained in the container content packages, but this is often not best because you have to unwrap it in your content package to actually see what is inside. So there's definitely still some gap in here. But let's first have a look at what kind of namespacing rules you might want to establish. This is something we came up with for that particular project I mentioned in the past. So some things are more obvious than others. So obviously, repositories need to be separated. So you need to make sure that the code does not overwrite something from another tenant. The content needs to be separated. That also involves the packages, users and groups, query index definitions, Java packages. I don't want to go into detail of all of those, but basically, I already mentioned, there is this tool here, and this tool is an open source tool which I published on GitHub, and the other tool is published by Maven. And they cover the following rules, basically. So you see there's still some gaps, but it's okay, I would say. It's a good start. So how does it look like if I want to use it? So the AEM content package namespace validator looks like following. So it is just a plugin for the firewall package Maven plugin. So a plugin of a plugin. So you add it as a dependency to that plugin. That would be the first step. And the next step would be that you actually configure that. And the configuration actually reflect your namespacing rules. In this particular example, you see a rule related to client libraries, and that client library, each client library should have a category which matches the given pattern here. So it should start with that property tenant ID, which is replaced with a real value. So usually each tenant is being assigned a dedicated prefix. And this rule makes sure that each client library category that it sees in the code starts with that particular prefix. So let's do a quick demo here. So this is a project skeleton which I've basically set up, and I also pushed that to GitHub. So you find that in the references section of the slide. So feel free to check it out more in detail later on. So basically, what it does is it contains one tenant, which is called tenant A. Sorry for the the little font here, but at least the source code you see bigger. And then you do have shared code below shared. So in this demo, I want to focus on tenant. And what you can see here, I ran a build before, and the build was not successful, so there was a failure. So someone has been a nasty boy. The tenant A is not complying with our rules. So what is wrong here? So let's have a look at the error message here. So it says the client library category is not compliant. Okay, let's try to fix it. But before we actually fixing that, let me firstly show you the most important parts of that Maven project. So this is the parent POM, which is also the root POM, and that parent POM contains this particular plugin, which is used for building the content packages. And within that plugin, you have the configuration for the namespace enforcer. And I do have several rules covering multiple aspects, like authorizable IDs, principal names, client library categories, filters, and so on and so forth. All rules basically follow the same pattern. That means you define which value is compliant, and that always relies on a regular expression pattern matching principle. So let's look a little bit into the tenant. So the tenant theoretically could be a Git submodule. For simplicity reasons here, I didn't leverage Git submodules. But the tenant should be pretty isolated. And the tenant itself contains its own OSGI bundle, its own components, configuration, and so on and so forth. So let's try to make the tenant compliant. The first thing which probably comes to mind is, which is not being mentioned in here yet. So let's first fix the error which is being mentioned in here, which is around the client library category. So you can see in here that this is also emitting an error marker in Eclipse. And let's try to fix it. So what is actually being wrong is emitted here in the problems view, and the category is not compliant. So let's see if I can come up with a compliant name. So yeah, I think it was underscore, and then let's say this is something like component A, for example. And let's save it, and what you see is that the problem disappears immediately, so no need for a build round trip. And let's continue with the other error markers basically in the project. There is another one which is being in the filter. So the filter is not compliant because the tenant tries to write something in the repository outside of his namespace. So let's remove that one. So obviously that tenant should not be allowed to overwrite something on the shared area. Okay, that one was easy. So at least the first module looks good now. So this is UI apps. Let's look into OSGI configurations. And you see in here the tenant has multiple ones. So one is leveraging a custom PID, and the custom PID is fully compliant because it uses the tenant prefix in it. Then it has another one, and this one is obviously not compliant because it's a global one. So this does affect the JCR resource bundle provider, so it affects internationalization in AEM overall. So this does not belong here, so you have to remove it here, or you have to at least move it to shared to be compliant. And the next thing is an interesting part because that is in fact a global service, but it uses the factory pattern. And in most cases, the factory pattern gives you a hint that this already supports multi-tenancy to a certain degree. So the tool is not perfect. It doesn't cover all of the cases, but in most of the cases, you want to allow those factory patterns also within the tenants, and you need to make manually sure that actually the tenant which is being used within the configuration is the right one. In here, it is the right one. Let's quickly confirm that. Okay, that should be the bundle symbolic name of the tenant bundle, so that should be fine, and that should not conflict with anyone else. Good, let's see quickly. I do have very little time left, so it could be that I actually missed one fix. Let's see. Yeah, I do, but that's good. At least UI apps and UI config, they build fine now, but still there's an issue in the container package. And let's have a closer look at the container package because that's interesting. First of all, that container package needs to mention the shared code base. And why is that? Because the bundle has a dependency on the shared bundle. So that dependency you see in here, I come up with a custom tenant-specific service, but that service is referencing another service from the shared bundle. So that is important that you then obviously make AEM Analyzer plugin aware of that fact that this always is deployed in parallel to the shared all package. And the last one, which I need to fix, is the bundle symbolic name, which is also wrong. You can see that also in here, somewhere above. But since time is up, let me just try to fix that. And let's see, but yeah, okay, now tenant is good. I can probably safely deploy it, but obviously you should manually confirm still that the code is fully compliant. I already mentioned this is not covering everything. So what is still missing is, from my perspective, a B&D plugin, which evaluates OSGI headers directly on the OSGI bundle level. So for example, import packages, export packages, Sling servlet paths, resource types you register for, or which OSGI services are being implemented. Let's skip the part around Sling API regions. There is some interesting ideas in that. Unfortunately, Sling API regions are only usable by Adobe right now because you cannot directly deploy a Sling feature. You always deploy a content package only. And the last thing I want to make you aware of is permissions. You need to keep an eye on permissions. So Cloud Manager, meanwhile, support program-specific permissions. Those require some manual setup, but they are available. And in AEM, you somehow need to do that manually. So there is different tools for leveraging that. The AC tool has added support for AEMaaCS. So what the AC tool can do is you can automatically deploy tenant-specific groups inside AEMaaCS. So you immediately see that in the admin console. And with that, I think I skipped the summary. So if you read it later on, this is the important points I want you to remember. And thanks a lot for the attention.
Konrad, when you would start from scratch, from the two options for a full stack repo, which one would you go for? Git submodules or a monorepo with well-designed Maven modules?
I would always go for Git submodules because it allows for better decoupling, especially if you have a lot of teams you need to work with. As I already said, one opportunity for the teams working on a single tenant only is to hide basically all the other parts. And with the monorepo, that hiding aspect is much more complicated.
Yeah, multi-tenancies comes with a bunch of process complexities. We have like different release cycles, ad hoc hotfixes, CDN changes where like the whole teams have to review and so on. What's your experience with such issues? Do you still recommend having shared programs for such setups?
Yeah, I think even if you plan to have dedicated programs, my experience is you always end up with multiple applications on the same program for reasons that are not only financial, but also sometimes it's just not fast enough that you can purchase additional licenses and business just wants to launch another completely separate AEM application, so you just have to deploy it somewhere. So I would recommend, even if you start from scratch with individual programs, keep those tenancy rules already in mind.
And to sum it up, what is the most important aspect for long-term success regarding such platforms?
As always, people, I would say. You guys in the end.
All right, thank you, Konrad. It was great to have you on stage.